All right, let's talk about one of the most common, most tempting mistakes in all of math. Seriously, it's a trap that looks so right, so logical, but trust me, it's going to trip you up almost every single time.
So, be honest with me for a second. Have you ever been there? You're looking at a problem, you see that square root sign sitting over two numbers being added together, and your brain just screams, "Hey, just split them apart." Yeah? If you felt that urge, you are in very, very good company.
And this is it. This is the classic trap. On the surface, it just feels right, doesn't it? I mean, it kind of looks like other rules we learn in algebra. But here's the thing, and what we're going to prove today. This idea, as intuitive as it seems, is just plain wrong.
Okay, so let's get into it. But hey, don't just take my word for it. Let's actually put this thing on trial. We're going to grab some easy numbers and see if this so-called rule can survive a little test.
All right, so here's our setup. We're going to use two numbers everyone knows, 9 and 16. So on one side, we'll do it the proper way. Add 9 and 16 first, and then take the square root of the whole thing. On the other side, we'll try the trap way. Take the square root of 9, take the square root of 16, and then add them up. Now, if the trap isn't really a trap, these two answers should be exactly the same, right?
So, let's crunch the numbers. Over on the left, we add first. 9 plus 16, that's 25. And the square root of 25 is, of course, 5. Simple enough. Okay, now for the other side. The square root of 9 is 3. The square root of 16 is 4. And what's 3 plus 4? Well, it's 7. Houston, we have a problem.
And yeah, there it is. 5 is not equal to 7. Not even close. Our two little experiments gave us totally different answers. So the trap is real. So there you have it. With just one super simple example, the myth is totally busted. And believe me, this isn't some weird fluke with the numbers 9 and 16. Oh no, this shows us something really fundamental about how square roots actually behave.
This is really the heart of the matter. You got to think of that plus sign inside the square root like a brick wall. You can't just break through it. See, with multiplication, you can distribute a square root. But with addition or subtraction, no way. It's one of the hard and fast rules of math.
But why? Why doesn't it work? To really get to the bottom of this mystery, we've got to do a little, let's call it an algebraic autopsy. Let's pretend for a second that our trap equation is true and see where that crazy idea leads us.
Okay, let's walk through this. First, we just assume the thing we know is wrong is actually right. To make things easier and get rid of those pesky square roots, let's just square both sides of the equation. Now, the left side is easy, right? It just becomes a plus b, but the right side, that gets interesting. It becomes a plus b plus this extra little term, 2 times the square root of a times b. So now we can just subtract the a and the b from both sides and see what's left over.
And look at that. After all that work, our big, complicated assumption boils down to this one tiny little equation. It's telling us that 0 has to equal 2 times the square root of a times b.
Now this is where it gets really interesting. We just proved the original idea is almost always wrong. But this final result, it opens up a new question. Is there ever a time when it could be true? I mean, when is it possible for 0 to equal 2 times the square root of ab?
And that question leads us right here to something I like to call the zero exception, because it turns out there is one very specific, very narrow case where our little math trap isn't actually a trap.
Okay, so let's just follow the logic here. For that whole equation to equal 0, the part with the square root of a times b, that has to be 0. And well, how do you get a square root of 0? The stuff inside has to be 0. So a times b must be 0. And when does that happen? The only way to multiply two numbers and get 0 is if one of them or both of them is 0. And that's it. That's the one and only exception.
Okay, so we've spent all this time talking about what not to do. So what's the right way to think about this? What's the real rule we should be using instead? Here it is. The real relationship isn't an equal sign at all. It's an inequality. The truth is that the square root of a plus b is always going to be less than or equal to the square root of a plus the square root of b. And this is true for any positive numbers you can possibly throw at it.
And just to prove it, let's circle all the way back to our first example with 9 and 16. We found out that 5 doesn't equal 7, right?
But is 5 less than or equal to 7? You bet it is. See? Our example fits the real rule perfectly.
So, if you remember just one thing from all this, let it be this. Just burn this into your brain. Never split a square root over addition. It's that simple. Now you don't just know about the trap. You know exactly why it's a trap, and you have the real rule to make sure you never fall for it again.